3.5 in Advanced Algebra 1 is about inverse relation. An inverse is quite simply just switching x and y around. Like inverses in general in math, like the inverse of addition is subtraction, the inverse of multiplication is division, right? So the inverse of a relation is to switch x and y around. So you can see here, this is a relation. It's a set of ordered pairs. If x is 4 and y is 7, we're just going to switch that around and get 7, 4 back. So you can see that I did that with every single one of these. It's still a set, right? But all I had to do was switch x and y around. The 7 was the y, it became the x was the 4, it became the y in that case. So you do that again here to write the inverse of this. The inverse of -9, -5 is -9. Well, I said it wrong. The inverse of -5, -9 is -9, -5, and etc. You just switch x and y around. When you type it in, make sure you got a comma in between. Not quite sure if they're going to make you put the set brackets or not. Just pay attention to how the question is written. You do the same thing on a table. They got, here's your x's and here's your y's, even though they call them f of x's, you know. So all you have to do is switch them around. But we get introduced to a new little notification symbol right here. It looks like f to like the -1 of x. This is really the symbol for inverse. So that's f inverse of x in that case. So we'll do that on the last one. All you have to do is just switch x and y around, and that's how you find the inverse of each other. It's a major, major easy move. Just switch an x and y around. To do that on a graph, that's really cool also. So you see they give me this black line right here, which I'll kind of highlight green for a second. But I noticed there's some ordered pairs. I kind of wrote them out already. To graph the inverse of this, it's real simple. You just switch x and y around. So if this point's 6, 4, I need to graph 4, 6. We've got to be kind of careful because these tick marks here are going by 2s. This is 2, 4, 6, 8. So watch what you're graphing, but that's 4, 6. 0, 6, if I switch that around, it goes to 6, 0, which would be right here. And then -6, 8 would go to 8, -6, which is right there. So I graph those points right there, and then I connect them together with my straight edge. And what's pretty cool is, we'll notice something here, is that I also had the line y equals x graphed as a dashed line. Well, I'm going to kind of twist this thing around, which I already did for you, and I'll highlight that guy orange. That is the line y equals x, which is just this line. I just kind of turned my graph, and can you see that these two lines, the blue line and the green line, like reflect to each other over the line y equals x? Because that's what an inverse is. You let y equal x, and you let x equal y. So on this guy right here, they gave me this black line already graphed. I found its ordered pairs. I'm just going to switch. -2, 6 becomes 6, -2, which is right here. -3, 0 goes to 0, -3. So it's like halfway in between -2 and -3 right there. And then -4, -6 goes to -6, -4, which is right there. And then I'll take my straight edge and connect those together. And because these guys are inverses of each other, they reflect to each other over the line y equals x. That's going to be a really important thing right here. Those reflect to each other over the line y equals x. So why don't you pause the video and see if you can get number 7 done for me. Here's the ordered pairs that were listed when I do the old switcheroo on them. The interesting one was this guy right here, -8, -8, is actually on the line y equals x. So like when you switch them around, you still get -8, -8 in that case. So these are inverses of each other. They reflect to each other over the line y equals x. So they'll have you do that on My Open Math right here. They'll have a cool little function graphed is what I should say, and they say, hey, can you graph like the inverse of this guy? Well, I don't think they're going to have this for you, but knowing that these guys reflect to each other over the line y equals x is a big deal. So as you can see, here's definitely an ordered pair that you know for sure. It's the little end of that guy at 2, -1. I found another nice, neat little spot right here at 3, -2. And I'm just going to use those 2 points. That's what you'll do on your homework also, to like graph the inverse of those. So 2, -1 becomes -1, 2. It's going to be like right there. And then 2, 3, negative 2, we'll switch those around and I'll get this guy. But the thing is, like, how do you connect the dots together, right? Like, especially if you're doing it on paper. Like, this just doesn't work, you know? It's like, because those two guys do not reflect to each other over the line y equals x. You need to graph it a little more like this, to where if you turn that to the side, like this dude right here and this dude right here are mirror images of each other if you fold it over the line y equals x. So that's just little facts about inverses. Now let's write the equation of the inverses. So they give me a function. They would like us to write the equation. There's a 4-step process to do it, and I'm going to make you number all the steps. So it's really pretty simple once you get used to it. It's kind of weird at first. So the first thing is they got us in function notation, this f of x. We don't like that, right? You know, we don't like it. So we're going to change f of x to y. So I'm just going to rewrite the whole problem, but where there's an f of x, I'm changing him to a y. So that's just to help our brain out. Step 2 is the true inverse step. Inverses, you just switch x and y around. So where there's a y, he's going to be an x, and where there's an x, he's going to be a y. You see how all I did was switch x and y around. That is truly the inverse step. And honestly, this could be a final answer in a lot of cases, but most people don't like it because we like our equations when y is all by itself. So that's step 3. We are going to solve this for y. So my first move will be to add 3 over. So this is going to be x plus 3 equals 4y. And I just added 3 to both sides. And then I'm going to divide by 4. So I'll show the baby step again. If you want to skip that, you can. Like, sometimes we divide the whole side by 4. Sometimes we divide the individual terms by 4. I don't care. Either one is acceptable. So this would be y equals, because those canceled out, x plus 3 all over 4. I'm not the biggest fan of that, though, because that's hard to graph because it's not like in slope-intercept form. So what we're going to do is use an eraser instead of a pen there. I'm going to divide every term by 4. So that would be like this, to where that 3 got divided by 4, and so did this x. That would be 1/4 x, because there's a 1 up there, plus 3/4. I think that would be easier to graph. So that's step 3. Get y all by itself. And then step 4, we're going to change it back to function notation. But since this is the inverse, we're not going to put f of x. We're going to put f inverse of x. That's that weird little -1 guy right there. And all I'm doing is just switching them from one side to the other. So like this one over here and that one over there. And I change the y to an f of x, f inverse of x. So weird, the 4-step process. Step 1. Change f of x to y. Got it. Step 2 is the true inverse step. Switch x and y around. So I have done that. Step 3, make our life easier by solving for y. So I'm going to subtract 7. And then I'm going to divide by a -3. I think showing the baby steps on that kind of helps a lot of people. So I'll show the baby steps there. There is a 1 up there. So this is -1/3 x. Sorry, my pen freaked out right there. -1/3 x. And then this is plus because it's minus over a minus. So plus 7/3 equals y. So I solve both of those, solve that for y. And then step 4, we're going to rewrite it with the f inverse, and I'm going to make them switch around too, so I get y on the left and all the other stuff on the right. So f inverse of x equals -1/3 x plus 7/3. If I graph this guy and this guy, they would reflect to each other over the line y equals x. So let's try that again. 4-step process. Step 1. Changing that dude to a y. Step 2, switch x and y around. Step 3, solve for y. So I'm going to add 8 over. And then here, I do not like that little 3/2 in there. So what I'm going to do is just get rid of it one at a time. So I hate this divide by 2. I'm going to multiply everything times 2. Here's a little bit of baby step for you if you want to see that. So this 2 times x would become 2x. This 2 times 8 would be 16. And this times 2 and divide by 2 cancel each other out. And you're left with the 3 and the y is still with it. Then, so that's Then we got to divide everything by 3. So bada boom, bada boom, bada boom. And I get 2/3 x plus 16/3 equals y. So finally, step 4. Again, I don't care that they're all stacked on top of each other. I just needed to number their steps. So I kind of ran out of room. So I went to a new area. F inverse of x equals 2/3 x. Sorry, I totally ran out of room. Plus 16/3. So try not to stack those on top of each other. So it's just the 4-step process, but these other ones are just little weirdos, right? You know, so I think we kind of get it, but now let's get into some weird situations. So step 1, change f of x to y. 3x minus 1 all over 6. Step 2, switch x and y around. And then step 3 is solve for y. And here's kind of like the weird difference between this number 4 and number 3. Like they both have fractions with them, but you see back here on number 3, it wasn't like what we call an all over. Like the divide by 2 is only happened in that one spot. Here, this is an all over 6. Like all of that is over 6. So we want to get rid of that first because this is truly a grouping symbol. You've got two groups, the numerator and the denominator. Like we can't do anything in here until we kind of deal with them. So I would like to get rid of that divide by 6 first. So if I get rid of that divide by 6, that's going to multiply both sides by 6. So that's going to make that a 6x, and those cancel each other out. And what you're left with is whatever that green blob is, it's 3x minus 1. Like not all of it gets times 6 because the times 6 and the divide by 6 canceled each other out, and that's supposed to be a y, not an x. Sorry about that. And now I'll keep solving for y. Now I'll add 1 to both sides, and then I'll divide everything by 3. So 2x plus 1/3. If you want to show the baby steps, you're welcome to do that, but that's what that dude turned out to be. And then step 4, we got f inverse of x equals 2x plus 1/3. So pretty neat. Another little weird boy here. A lot of people think they should distribute the 3 through the parentheses. You totally can. There's nothing wrong with it. I'll show you how to deal with it if you don't want to distribute. So same old starting moves. Switching, sorry, I got ahead of myself. Switching f of x into y. That's step 1. Change f of x to y. Step 2, switch x and y around. So bada boom. Then what you could do is distribute the 3 if you wanted to. It's probably an easy move, right? I think that would be a little nicer for us here, so let's do that, right? Let's distribute the 3 through the parentheses. So that would be 3y minus 15. I think that's a pretty easy move right there. Then we add 15 to both sides. So this is step 3, sorry. Plus 15 equals 3y. And then we got to divide every term by 3. Which was pretty nice. That's 1/3 x plus 5 equals y. And then finally, f inverse of x equals 1/3 x plus 5. So there we go right there. So I'll let you try number 6. The last two are kind of weird. I'll do them with you. But I want you to try number 6. Please pause the video and check yours with mine. So move 1, change f of x to y. I think we do really good with that. Move 2, switch x and y around. We do really good with that. It's the solving for y. That's the tough part. So this is not one of those all over guys. He's just a normal little fraction. So I want to move this minus 15 over to the other side first. So I added 15 to the other side. Then with this stupid little fraction right here, I would like to get rid of that divide by 5. So I will multiply all 3 places times 5. If you need to show a little baby step right there to do that, that's pretty helpful in that case, but I multiplied everything times 5. And then I would like to divide everything by -3, right? You see he's a -3, so that becomes a -5 over 3x. This is a minus 25, and then there's our y to where we get our final answer. So those are some normal guys. Here's a weird dude. This is a square root function, right? But the process still stays the same. So First, we're changing f of x to y. So, bada boom. Second, we need to switch x and y around. Things that we're really, really good at. But you see how all this junk right here is underneath of this square root symbol? We need to get rid of the square root by squaring both sides. So this x becomes an x squared, when I call that step 3, and this square and square root cancel each other out, and you're left with just whatever's underneath there, which in this case is 2y plus 1. Then we could solve for y by subtracting 1. We're just trying to get y by itself, so it's going to be x squared minus 1 equals 2y. And then you could divide everything by 2 to get that done. So that would be all over 2, all over 2, all over 2, like 1/2 x squared minus 1/2. It's also okay if you had x squared minus 1 all over 2. Like, they mean the same thing. I just kind of like to split them up into two little dudes right there. So, got all that. And, of course, step 4 is to rewrite it with the f inverse. F inverse of x is going to be 1/2 x squared minus 1/2. If we graph this and we graph this, they reflect to each other over the line y equals x. And we'll do that again. So step 1, changing this to a y. Step 2, switching x and y around. Same old process. Got a stupid square root? I will get rid of it by squaring both sides. So step 3 here is this. We are going to then start solving for y, so I need to get rid of that minus 4 by adding 4 to both sides. So that would be 3y equals x squared plus 4. And then we're going to divide by 3. And this time I'll write it just to be a little different. You could divide each term by it, but you can use the all over 3 if you really wanted to as well. And then f inverse of x is going to equal x squared plus 4 all over 3, man. So, weird stuff. Inverses and their equations, the 4-step process. Let us know if you have any questions. Have a good one.